Good afternoon, my dear students. Today we're going to have another virtual class for Math 6103. This is Calculus 2. Today we're going to discuss your applications of Derivative 1, which is already in week 10. Today is November 17, 2021. Our schedule is 1:10 to 2:40 p.m. So these are the applications of Derivatives 1. In the previous sessions, we focused almost exclusively on the computations of derivatives. This topic will focus on applications of derivatives. At the end of this session, students will be able to use the derivative to determine the critical points, the absolute minimum and maximum values of a function. So these are our objectives. So what is a critical point? A point in the domain of a function f at which or does not exist is a critical point of f. Note, maximum and minimum points in the interior of a function always occur at critical points. So ito, no? Maximum and minimum points in the interior of a function always occur at critical points. But critical points are not always maximum or minimum values. Okay? So we already discussed with you already the derivatives 1, derivatives 2, and the derivatives 3. So by this time, we have now the applications of derivative 1. Okay? So this is now your example number 1. Determine all the critical points for the function of x equal to 6x to the 5th plus 33x to the 4th minus 30x cubed plus 100. Okay? So solution, first we need to find the derivative of the function in order to find the critical points. And so let's get that, and notice that we'll factor it as much as possible to make it easier when we go to find the critical points. So first we're going to apply the power rule formula, no? Okay? So this is our exponent. Okay? Then this is our base, no? So 5, we're going to get the first derivative, f prime po siya. 5 times 6, we have 30. 5 minus 1 is 4. So we have 30x to the 4th. 4 by 33, we have 132. 4 minus 1, we have x cubed. 3 by 30, we have 90. X cubed minus 1, we have x squared. And then, derivative of 100 is 0. Okay? So by this time, since x is common to all the three terms, and the lowest exponent is 2, we're going to take that one as the common factor. And also we have 6, no? For this numerical value. So if we're going to have this one, the common factor is 6x squared multiplied by 5x squared plus 22x minus 15. 6 by 5, 30x to the 4th. 6 plus by 22, we have 132x cubed. No? 6x squared by 15, we have 90x squared. So next, we are going to factor this one, no? 5x squared, 22, and 15. So if we're going to factor this one is a perfect trinomial. If we're going to factor that, we have 5x minus 3, and then we have x plus 5. 5 by x, we have 5x squared. 5x by 5 is 25x, minus 3 by x is negative 3x, so we have 22x. Okay? Then negative 3 by 5, we have negative 15. So this is the factor of this trinomial. So with that, now our derivatives is a polynomial, and so will exist everywhere. Therefore, the only critical points will be those values of x which make the derivative 0. So we must solve 6x squared multiplied by 5x minus 3 multiplied by x plus 5 is equal to 0. Okay? So we're going to equate this one into 0. Because this is the factored form of the derivative, it's pretty easy to identify the three critical points and they are, okay? So ito yung magiging tatlong critical points pa natin. We have x plus 5 is equal to 0. We have x minus 5. Okay? And then 5x minus 3. So 5x minus 3 is equal to 0. So we have 5x plus 3 or x equal to 3 all over 5. 6x squared is equal to 0. So therefore, x will be equivalent to 0. So these are now the three critical points of our function. We have x is equal to negative 5, x is equal to 0, and x is equal to 3 all over 5. Okay? So if you're going to grab that one, ito siya, no? Since you have your second degree parabola, okay? So we have x is equal to negative 5, and x is equal to 0, the other one is 3 all over 5. Okay? So that's our critical point. Next, we have your another example. H of t is equal to 10t e raised to 3 minus t squared. So we're going to apply the formula for logarithm, no? Okay, solution. Here's the derivative for this function. Okay, so if we're going to look on our equation, we have 10t e to the 3 minus t squared. Okay, so if we're going to have that 10e muna, then 3 minus t squared. So it's a combination of u and v. Okay, so u and v, we have v du plus u dv. So if we're going to have that one, u, 10e 3 raised to negative t squared, derivative ng t is 1. Okay? Then, we have derivative nito, 10t e to 3 raised to negative t squared. Okay? So ito, no? 10e na, no? Derivative ng t squared is negative 2t. So this is our u, this is our v, no? So we have u dv plus v du. V du natin is 10e 3 minus t squared. Okay? So, ito yung kukunin natin na derivative, yung e raised to 3 negative t squared. So, derivative ng t squared is negative 2t. So, we have 10e 3 negative t squared minus, okay, itong dalawa, 20 t squared e raised to 3 minus t squared. Now, do factoring to clean things up a little as follows. So with this one, common yung 10e 3 raised to negative t squared. So this is their common factor, 10e 3 raised to negative t squared multiplied by 1 minus 2t squared. So parang ito po yung ginawa po natin, no? Ginawa natin yung factor para makuha yung critical points po natin. Okay? So that's now the factor of this equation. So this function will exist everywhere. And so, no critical points. Well, will come from that, no? Determine where this is 0 is easier than it looks like. Okay? We know that exponentials are never 0, and so the only way the derivative will be 0 is if, so gagawin po natin, we're going to equate this one into 0. Then, e to the 3 negative t squared, h prime equal to 0 yan, no? Equate po natin. Tulad po yung ginawa po natin dito, equate natin to 0. Okay? Then, e raised to negative 3 minus t squared is equal to 0. Okay siya to. So, mangyayari ba doon? The value is 0 na po siya. 1 minus 2t squared is equal to 0. So, ito na siya. 1 minus 2t squared is equal to 0. So 1 is equal to, transpose natin yan, maging 2t squared. Or 1 half is equal to t squared. So there are two critical points for this function. T will be plus or minus 1 all over square root of 2. So that's our critical point. Okay? So that's the way how we're going to look for the critical points of a given functions. Next, we have the absolute extreme values are either maximum or minimum points on a curve. They are sometimes called global extremes. They are also sometimes called absolute extrema. Extrema is the plural of the Latin extremum. Extreme values can be in the interior or the end points of the function. So that's our absolute extreme values, either maximum or minimum points on a curve. So this is our illustration. So y is equal to x squared. This is now the equation of your parabola. So dito, there's no absolute maximum, and at point 0, that is your absolute minimum. So yung distance po natin from negative infinity to positive infinity. Kaya tinawag nilang no absolute maximum dahil yung x values po natin from negative infinity to positive infinity. So wala siyang limit, no? Kasi may arrow po siya. Kaya tinawag nilang no absolute maximum. Next, we have your another figure. The same formula, y is equal to x squared. By this time, your distance is x1 is 0, x2 is 2. Okay? x1 is 0, x2 is 2. So we have now the absolute maximum and the absolute minimum. So paano tayo nagkaroon ng absolute, no? So if we're going to look on our first example, there is no absolute, no? Dito meron siya kasi nandito yung absolute minimum niya, nasa baba. So dito, naka-specify na meron tayong absolute kasi meron tayong tinatawag na solid dot. Okay? So, if you can recall, your solid dot, ibig sabihin, that is now the point of intersection for a continuous function. So, solid dot, kaya absolute maximum, absolute minimum. If x is equal to 2, okay, your y is equal to 4. Ito na po siya. So, that's our limit. Next, y squared, pareho pa rin. This is our graph from 0 to 2. Okay? 0 to 2. If x is equal to 2, y is equal to 4. So by this time, meron tayong absolute maximum pa rin. Dahil solid dot po siya. Dito, meron tayong no minimum. Kasi meron tayong hindi solid dot sa hollow circle, no? So if we're going to look on our discussion noon, if you can still recall, so this is what we call the undefined limit. Okay? Kaya tinawag nilang no minimum because it is undefined limit. Pero doon sa absolute maximum, there is what we call a solid dot, and that is defined limit. It is a part of the continuous function. O, dito, pareho pa rin, y is equal to x squared. Distance, x1 is 0, x2 is equal to 2. So, no absolute maximum, no minimum. Again, hindi po siya solid dot. Kaya this limit is undefined. Okay? Next, extreme value theorem. If f is continuous over a closed interval, then f has a maximum and minimum value over the interval. Okay? So in your first figure, the maximum and minimum at interior points. So this is your maximum, and this is your minimum. No? Sa interior po niya, no? Maximum value, minimum value, no? Maximum and minimum at endpoints. So this is your maximum, and this is your minimum. Maximum at interior points. So this is our interior points. Okay? Minimum at endpoints. Ito yung minimum po niya. So next we have your D, local extreme values. A local maximum is the maximum value with some open interval. A local minimum is the minimum value within some open interval. Okay? So local extreme are also called relative extreme. So this now the absolute minimum, also local minimum, no? Ito po siya. Then we have your the local maximum, open interval po siya, and this your local minimum with some open interval. Okay? Ito po siya. Absolute or local maximum, okay? Then we have your the local minimum. So if we're going to look at our figure, notice the local extremes and the interior of the function occur where f prime is 0 or f prime is undefined. So this is your local maximum, local minimum, this is your absolute maximum or local maximum. Kaya sabi niya, notice that the local extremes in the interior of the function occur where f prime is 0 or f is undefined. Kaya tawag dito, pag titingnan po natin, wala tayong, ang, ang tawag po natin dito, yung slope natin is 0 or 0. At the same time, we call that undefined. Kaya kanina, yung dito, yung mga small circle po dito na hindi solid dot, ang tawag po doon, these are all undefined. Kaya, no no minimum dito, no absolute maximum. Kasi undefined po sila. Okay? Paano nasabing na undefined dito? Pag yung functions po natin, nag-substitute po tayo, lalo na sa division, doon sa quotient rule, tapos yung denominator natin is 0, that is what we call the undefined limit or undefined function. Kaya pag naging 0 po yan, ang gagawin po natin, we're going to find their common factor para hindi maging 0 yung denominator po niya. Yun po yung tinatawag nilang undefined limit. Okay? So example number 1, identify the absolute extrema and relative extrema for the following functions. Solution. So since these functions is easy enough to graph, let's do that. However, we only want to graph of the interval at -1 and 2. So here is the graph, no? So dito meron tayong solid dot, meron tayong solid dot. So figure 6, graph of f of x is equal to x squared on -1, that is our x1, and we have your 2, that is our x2. Okay? So notice that we use dots at the end of the graph to remind us that the graph ends at these points. Kaya mayroon kayong dots. Sa solid dot, ibig sabihin ito na yung define po niya, no? So there is a maximum value, no? So naka-define po siya from -1 and 2. We can now identify the extrema from the graph. It looks like we get a relative and absolute minimum of 0 at x is equal to 0. So this is your absolute minimum, this is your absolute maximum. An absolute maximum of 4 at x is equal to 2. So absolute maximum at x is equal to 2 and y is equal to 4. So nandito yung absolute maximum po niya. Kaya sabi niya, note that x is equal to 1 is not a relative maximum since it is at the end point of the interval. Okay? So note that x is equal to 1 is not a relative maximum since it is at the end of the point interval. Kasi pag titingnan po natin sa figure po natin, if x is equal to 1, yun po yung n ng interval natin. So, nandito po siya. Susunod ulit, nandito na. Kaya hindi po siya tinawag na relative maximum. Dahil yung absolute maximum natin, nandun siya sa x is equal to 2, which is equivalent to 4. Okay? So this function doesn't have any relative maximum. Okay? So next, last problem. Last slide na rin ata to, no? Example 3, identify the absolute extrema and relative extrema for the following function. J sub t is equal to 2t raised to 3 plus 3t squared minus 12t plus 4 on -4 and 2. Okay, so this is our endpoints, no? From -4 to 2, no? Solution, all we really need to do here is follow the given procedure. So first notice that this is a polynomial, and so in the continuous everywhere, and in particular is then continuous on the given interval. So the first thing we are going to do, now we need to get the first derivative so that we can find the critical points of the function. Okay? So since this one is a polynomial, so we're going to get the first derivative, g prime t, we have 3 by 2, 6t squared. 2 by 3, 6t. 1 by -12, we have -12. Okay? So this is now the first derivative of this polynomial. 6t squared plus 6t minus 12. And if we're going to look on that one, 6 is a common factor to the three terms, no? 6, 6, ito 12 din ito, no? 6, pwede siya sa 6. So we have 6 multiplied by t squared plus t minus 2. Okay? If we're going to factor that one, we have 6 multiplied by t squared plus t minus 2. So if we're going to factor t squared plus t minus 2, we're going to have t plus 2 multiplied by t minus 1. So doon po galing yung binomial na ito, no? Kasi pag finactor mo yan, 6t squared plus t minus 2. So if we're going to factor t squared plus t minus 2, t plus 2, and then t minus 1. So sabi dito, it looks like we'll have two critical points, no? So magkakaroon po tayo ng two critical points. At t is equal to -2. Okay? And t is equal to 1. So saan po nakuha yun? So tulad po ng ginawa natin sa una, we're going to equate all the values of this one after getting their first derivative into 0. So we have 6 quantity t plus 2 multiplied by t minus 1 is equal to 0. So we have t minus 1 is equal to 0. So we have t is equal to 1. T plus 2 is equal to 0. So our t is equal to -2. 6 is equal to 0. So we have 0. So this is now our critical points. Okay? Which is -2 and +1. Note that we actually want something more than just the critical points. We only want the critical points of the function that lie in the interval in questions. Both of these do fall in the interval, as so we will use both of them. Okay? So we have our equations, no? So gagamitin po natin yung mga critical point natin at yung mga nandito. Okay? So if x is equal to, or t is equal to -2, and if we're going to substitute it here, okay, if g, which is a function of t, and t is equal to -2, we're going to have here, the answer is 24. The same with our, if t is equals to 1, okay, which g, which is a function of t, which is equal to 1, And if we're going to substitute it here, the value is equal to negative 3. And also, from the given coordinates, x1 at saka x2, okay, ito yung mga value ng limit po natin, no? Which is in terms of t. Okay? So, if j is equal to negative 4, if we're going to substitute it here, the answer is negative 28. And j is equals to 2, okay? If we're going to substitute it here, is equal to 8. So, which means this is our absolute extrema, no? Yung positive value and relative extrema. Okay? Both of these do fall in the interval. So, nasa interval po sila, no? From negative 28, then we have negative 3, then we have 8, and 24. So, if this equals to negative 2, okay? So, if we're going to substitute it here, yan po yung magiging value niya. Okay? So, that is our solution. So that ends our discussion for today, which is all about the applications of the derivative one.